Shears are typically larger than scissors for heavier duty cutting. And you can insert up to 3 fingers in the handle's finger ring. Using more fingers gives you a stronger grasp, which translates into more control and more cutting force. These high-end shears effortlessly slice through produce, snip fresh herbs, and open packaging. Outside the kitchen, they easily cut many materials, including thin aluminum and galvanized steel. The secret to their strength? Blades made of stainless steel, which contains a minute amount of carbon. To make them, workers feed a bar of this high-carbon stainless steel into a press. It stamps out blade shapes called blanks. Stainless steel can be heat-treated to make it more durable and corrosion-resistant. But first, a furnace softens the blanks for the forging process that transforms them into blades. Each blank goes onto a forging die that has 2 blade-shaped cavities. 1 strike in each, and the blank is a blade. Once it cools, a trimming press cuts off all the excess metal around the perimeter. Heating and forging tend to warp steel, so another press makes the blade perfectly flat and straight again. Trimming the excess metal leaves some rough areas, so the next step is to smooth the surface with a sanding belt. To make the hole for the bolt on which the blades pivot, they drill a round hole partway through. Then pierce a rectangular hole through the rest. You'll see why later on. Now the blades undergo heat treatment. First, to harden them, a slow heating and rapid cooling. Then, to make them tough and durable, a reheat and slow cooling. A grinder shapes the round area next to the tang, the term for the metal core of the handle. With a sanding belt, they smooth out and blend the adjacent corners. Here, 2 polishing wheels give the surface an upscale satin finish. Then an etching machine uses electrically activated chemicals to imprint the company's name into the thumb-operated blade. Just one final step before the blades are finished. A computer-operated grinder serrates the inside edge of the thumb-operated blade. Workers now load 6 blades at a time into an injection molding machine. The machine shoots molten plastic into the cavities, then rapidly cools the material until it solidifies. Each blade exits the machine with a molded handle firmly encasing the tang. Now for the final assembly. First, they drive a bolt with a rectangular head into the pivot hole of the finger-operated blade. Then they add the thumb-operated blade and press the bolt again into its final position. A self-locking hexagonal nut secures the bolt from underneath. An automatic tightener does the initial fastening. Then, workers do the final tension adjustment manually. The final step is to grind the excess plastic off the handle stops. This enables the blade to close fully and in perfect alignment. So why the rectangular bolt? Watch closely. It allows you, with just one simple twist, to separate the blades for cleaning and then reassemble them. Now that's cutting-edge design.